Hello, welcome back all the participants. We now have our second speaker, respected Dr. Rashiddeep Kaur. Welcome ma'am, the Satsai College of Engineering, RKDF University. Welcomes you.
Hello, Dr. Sharma.
Hello.
Thank you for your welcome.
Thank you
Uh,
ma'am. Thank you for your patience. Thank you for making me wait. Sorry.
no worries, it's all fine. And let me share my screen first of all.
Ma'am, before that, let me have this honor to briefly introduce you.
Okay.
It is my privilege to introduce our esteemed expert speaker, Dr. Arashdeep Kaur, who is currently associated with the Department of Computer Science, Ying Wu College of Computing, New Jersey Institute of Technology, USA. Dr. Kaur brings with her more than 15 years of rich experience in teaching and research across leading universities worldwide. Her research interests span across diverse and impactful domains, including digital watermarking, artificial intelligence, machine learning, medical image processing, and software reliability. Dr. Kaur has contributed extensively to the academic community through numerous publications in reputed international and national journals and conferences. Alongside her research, Dr. Kaur has played a significant role in academic program design, curriculum development, and implementation of innovative educational initiatives. Her teaching portfolio is equally versatile, covering a wide range of courses such as artificial intelligence, digital image processing, data structures, design and analysis of algorithms, Python programming, MATLAB programming, and theory of automata and computation, to name a few. Beyond conventional classrooms, she has enriched learning by creating instructional videos as well as organizing workshops, webinars, FDPs, and international conferences, demonstrating her strong commitment to advancing education and research globally. We are truly very honored to have you with us today, and I now invite Dr. Arashdeep Kaur to deliver her expert session. Welcome, ma'am. Over to you.
Thank you, Dr. Gagan, for such a great introduction of me. Even I am not aware of many of my achievements which you just mentioned. Thank you so much.
Thank
All right, let me share my screen first so that we can start with the session. And I hope my screen is visible.
you. Yes, ma'am.
Yes.
Mm. All right, so hello everyone, and thank you for joining this session. And I would like to start my talk by putting on a question in mind so that we all will walk around with the same thought. So, whenever we think about cybersecurity, we often imagine a digital fortress, a set of static walls, and some moats which are designed to keep attackers out. But the reality today is that the attackers are incredibly dynamic and creative. They are no longer just trying to bash down the front door. What they are doing, they are finding new vulnerabilities every single day, and our traditional defenses are struggling to keep up. So, the question over here is how do we fight an adaptable, intelligent threat with the static, rule based defense? And today I want to explore how the very technology behind many of these new threats, such as artificial intelligence and machine learning, is also our most powerful tool for defense. I will explain what AI truly is, how it's different from machine learning, and show you how it can help us build a proactive rather than a reactive cybersecurity posture for the future. My name is Arashdeep Kaur and I am associated with Department of Computer Science at New Jersey Institute of Technology, USA. My research majorly focuses on the intersection of cybersecurity and artificial intelligence, not particularly the cybersecurity, with a particular emphasis on the digital watermarking. And nowadays, I am trying to develop new techniques to combat the dynamic and sophisticated threats that we are facing today. So, this talk will be a reflection of the work and the broader research happening in this field, and I'm excited to share it with you. This slide gives you the basic idea about my presentation, what I'm going to discuss today. So first of all, we will be seeking the problem, the evolving cyber threat landscape, how it is going through since the history, that is from dusk to dawn. Then we will see some of the latest technology defining artificial intelligence, machine learning, and deep learning in the context of cybersecurity. And then we will see how we can use these new and the latest technology in the field of cybersecurity as a defense. We will also see some of the future challenges and the road ahead. Now, at this point of time, I would like to take a moment to introduce you to my home institution, the New Jersey Institute of Technology. We also call it NJIT, and our Department of Computer Science. It is very exciting to know my home institution. This is a great place where I am working right now. NJIT is a leading state public university, and our core mission is to solve real world problems through technology and innovation. And we are particularly proud of our strong focus on hands on research and our close ties to industry, which ensures our work is both academically rigorous and practically relevant to the industry. We are located on a large 45-acre campus in the heart of Newark, New Jersey. We are proud to be New Jersey's only five-star rated public university. This is a big achievement for any public university here in the United States. NJIT is also ranked among the top 50 public national universities. It has been recognized as the number one public university in the nation for alumni earnings, economic mobility, and the academic profile. NGIT is a leading public university which offer various graduate and undergraduate courses, including doctoral degree programs, across 6 specialized schools. We have different schools like engineering, medical, law, and all taught by an expert faculty, and 90% of whom hold the highest degree in their field. It has achieved the highest research rating from the Carnegie classification. Again, another achievement by NGIT. Within the NGIT, the Department of Computer Science is at the forefront of this effort. We have vibrant research environment with a heavy emphasis on the cutting edge fields like artificial intelligence, machine learning, image processing, and of course, cybersecurity. But we are not limited only to these such research areas. We have a good funding from the NSF, Department of United States, Department of Defense, and other funding agencies. CSE department here at NGIT offers various degree programs and certificates. You can see over here a list of undergraduate, graduate, and the doctoral certificates. There are some graduate certificates too. We have our two major campuses. One is located in the Newark, which is the main campus, and another one is at the Jersey City. So both are operational and taught by the equal level of the faculty. We also offer some courses online. You can have a detail over here, or you can click on the website to explore more and see more. All right. So now that you know a little about my background, I want to give you a quick roadmap of what we will cover today. First, we will start with the problem itself, that why our traditional security models are struggling against modern threats. From there, what we will do, we will delve into how AI and machine learning offer a powerful solution. I will show you some real world applications and then as an example, connect these concepts to my own research on digital watermarking. And then finally, we will look at the exciting challenges and the future directions of this field. So I believe that this will give you a complete picture of the landscape we are operating in nowadays. Let's start by looking at the world we are trying to secure. So for decades, what we are doing, we are thinking about cybersecurity, that it's a game of cat and a mouse. But nowadays, the rules have been changed. Now the landscape is no longer static. It is evolving at an incredible pace. Now, where the problem actually exists? The core problem is that the existing static security models are simply not built for this new environment. Uh, let's consider an example. Think of a think of these items like a security guard with a book of wanted posters. And what they can do, they can stop the criminals they already know about. And this approach is failing us against the modern threats. Why? Because today's threats are intelligent and dynamic. Zero-day attacks, for instance, are exploits for vulnerabilities no one knows about yet. They bypass our rule books completely. Another thing, sophisticated phishing is no longer a generic email. It's personalized, it's convincing, and it's designed to trick both technology and people. And then we have polymorphic malware, which changes its code with every new infection and making it impossible for signature-based antivirus to keep up. So what happens over here? This leads us to the fundamental challenge we face. Attackers are highly creative and adaptable. What they are doing, they are constantly inventing new ways to breach our defenses. And on the other hand, our defenses are mostly often static and reactive. And now we are in a perceptual cycle of playing a catch up, and it's a battle we are currently losing right now. This is where AI and machine learning come in. So, what they do, they provide the adaptability we need to fight back. Now, we should answer that why AI? So, if our traditional defenses are too static, what's the solution? The answer lies in the technology that can mirror the adaptability of the attackers so that I can know from where my attackers is coming up and accordingly I can design my solutions. And the answer to this technology is artificial intelligence. Consider, for example, if I'm a human being and I am manually supposed to see that what attack can happen next, it is nearly impossible or actually impossible to see what attack can happen today, tomorrow, or maybe after some days. But this artificial intelligence has a good capability of doing such predictions. So, the biggest reason we need AI is its adaptability, first of all. Our static rule books, like if else, are like trying to fight a ghost with a sword, a static sword. They can't keep up. AI, on the other hand, can learn from data and continuously updates its understanding of what a threat should look like. It can identify patterns in a new attack that a human or traditional system would completely miss. Another thing that AI also provides the necessary speed and scale. A large enterprise network that generate millions of security events every day. So I would say it's an impossible task for a human team to shift from all of that data in the real time. Whereas, where on the other hand, an expert system can process this data instantly, identifying anomalies and flagging potential threats the moment they appear on the network. So this is the most crucial shift, and the AI's core strength is its predictive power. Instead of just reaching to breach after the fact, AI can analyze indicators and behaviors to predict that an attack is about to happen. So this allows us to get ahead of the curve instead of constantly playing catch up. Finally, AI helps us with the automated response. Once a threat is identified, AI can automate immediate actions like blocking a malicious IP address or isolating an infected machine. And this reduces the response times from hours to minutes and down to seconds. And this will effectively eventually minimize the damage. And this allows our skilled cybersecurity professionals to focus on the truly complex strategic security problems. And this is the future we need to embrace, we want to see. All right, so now that we have set the stage by understanding the dynamic nature of the threats, let's address a fundamental question that causes a lot of confusion. I would like to ask every one of you to just think about it and answer maybe in the chat if organizers allow you that are AI and machine learning the same thing? What are your thoughts on this? That artificial intelligence and machine learning, are these the same things? Or these are two different or separate things? All right. So when we hear artificial intelligence, most of us immediately think of the, self-driving cars, chatbots, or some facial recognition system, um, or maybe the speech recognition systems. These all are powered by the specific technology which is called as the machine learning. And this is where the misconception begins. In reality, AI is a broader concept. So I would like to tell over here that think of it like a big family. Artificial intelligence is the entire whole family representing the goal of creating machines that can mimic human intelligence. Dr. Gagan, did we get any answers on that,
Yeah,
whether
yes, yes.
AI or machine learning are same?
Yeah, people are saying they are two separate things, two different things.
Great, great. Nice. So definitely these are two different things, and let us use this simple visual to clarify this. Think of AI, machine learning, and deep learning as the nested concepts. Again, first of all, most of the students and the faculties, those who are not into AI, they have a misconception that whole artificial intelligence is machine learning. But there is a very nice saying that not all intelligent systems are machine learning. Some are rule based. So what does it mean? Artificial intelligence is not only machine learning or deep learning, there is a lot behind it. All right, so let us take this Venn diagram and think of it as a set of Russian dolls as shown here. The outermost circle over here represents artificial intelligence, and this is the oldest and the broadest field. The goal of the AI is to make machines think and behave in ways we consider intelligent. And this will also include everything from a simple rule-based system to complex modern algorithms. Let us consider an example. For example, if we write a program or a code saying if the value of the input variable ranges between 5 to 10, then print this one, else print another statement. So whenever a user is giving some input, and by understanding the input behavior, the machine is giving us some sort of output. Definitely, this is not the machine learning, but we will call it as the artificial intelligence because machine is behaving intelligently by reading the input. That is simply a rule-based system. We also call those systems as the artificially intelligent systems. But nowadays, the most trending parts are the machine learning and the deep learning algorithms. So inside that artificial intelligence umbrella, when the machines started learning by themselves, we called that concept as the machine learning. And this is a very popular and a powerful approach to building AI. Now, the key idea here is that instead of manually programming every rule, we give the machine and it learns the rule itself. So, for example, if we give a thousands of pictures to a machine of a cat or a dog or something else, what it does, it learns what a cat look like on its own. And finally, at the very center, we have deep learning. And this is a specialized and very advanced type of machine learning. What it does, it uses complex structures, and those structures are called as the neural networks. And these neural networks are inspired how the human brain works to learn incredibly from the large data sets. This deep learning is responsible for some of the biggest AI breakthroughs we have seen recently, like natural language processing, facial recognition, and more. So let me be precise and conclude this slide that all machine learning is a form of AI. These are not two separate fields. Machine learning is a part of AI, but not all AI is also machine learning. There is a huge behind this scene that AI is search as well. AI is probability also. AI is prediction. AI is recognition and more. And this distinction is crucial for understanding how we can leverage these technologies in cybersecurity, and we will explore that in our next section. Next section. With this in mind, let's look at how these technologies are different from each other. Uh, with the cybersecurity specific example, this is where on the left hand side, we have a classic example of AI. Very basic example, a firewall or an intrusion prevention system, which uses a set of pre-programmed rules For example, a network administrator has a list of 100 bad IP addresses, and they program the firewall to simply block any traffic coming from those addresses. The system is performing an intelligent task by protecting the network. But do you think it is actually doing the required job? It's not learning anything new. So it's only as good as the rules it was given. Now look at the right hand side. There is a machine learning. Now, instead of giving the system a list of bad IP addresses, we feed some terabytes of network traffic data, both good and bad. So the machine learning model's job is to learn over here what normal network behavior looks like. It identifies the subtle patterns and the connections that a human could never see and will generally miss in the pattern. So when a new connection come through that deviates significantly from the learned behavior, the learned normal behavior, the system flags it as a potential threat, even if it's from an IP address that no one has ever seen before. So finally, to conclude over this slide, that this is a key difference between the traditional AI and the machine learning. What traditional AI do, it is great for fighting threats we already know about. But machine learning is the tool that gives us the ability to fight tomorrow's threats today. So it's what allow us our security posture to evolve just as quickly as the attackers. So it's like a uh, balancing the offenses and the defenses in a better way. So while the buzz is all about the machine learning, I've always say that machine learning is the most trending thing nowadays. It's important to remember that the other forms of AI have been and still are crucial in cybersecurity. And those don't learn from data, but they perform intelligent automated tasks, as we have seen on the previous slide. And the most common example over here is the rule-based system. I always emphasize on the static part of AI because this is really the foundation from where AI start. And even nowadays, if you want to create a new cybersecurity system, a complete agent. I'm not talking about just the prediction or the recognition part. I'm talking about if you want to design a complete cybersecurity AI agent, this static AI plays an important role in there. So again, we can take the similar example, a network firewall as a digital gatekeeper. And just think that it has a static rules. And if an incoming connection matches a rule, if it's from an IP address or on a non-malicious list, the system knows exactly what to do. It will block it. This is very effective form of AI, but the limitation over here is obvious. Now we all know that it can only defend against what's already in the rule book. Another similar type of systems are the expert systems, and these were very popular in the late 90s. These are the most sophisticated ones, and they are built by taking the knowledge of the human expert. Let's consider a senior fraud investigator or a digital arrest investigator. And what we do, we encode all its knowledge into a computer program. Now, the system can use that knowledge to make decisions. For example, it might analyze a credit card transaction and determine its high risk because it has a combination of factors that an expert has identified as suspicious, maybe in the past. A large purchase in a unusual location, maybe followed by another purchase moments later. This is intelligent, but again, the system is constrained by the knowledge that was put into it. This one is one level above the static rule-based system because in this we are incorporating the expert knowledge into the system. It can't again identify the new type of fraud, which it has been never taught about. So again, same challenge we are facing with the expert systems. And these systems are the backbone of many security products. The rule-based systems and the expert system are very good at what they actually do. They have 100% success rate, whatever they have been taught. But they highlight the critical need for something more adaptable, and that something is called machine learning, which we are going to discuss after this slide. If you have a look at this seminal paper by Dorothy Denning, this one paper was published in 1987. And I would say this is the perfect starting point for those who really want to work in the field of the cybersecurity. This paper was published in IEEE Transactions on Software Engineering. This paper basically laid the groundwork for the modern intrusion detection systems. What this paper describes, if I can recall correctly, that the model for a real-time expert system, it gives a model that could detect various security violations by monitoring system behavior against a set of static rules. So it's a fantastic example of sophisticated AI system that relies on the program knowledge, not on learning from data to take intelligent decisions. It highlights the origins of our field basically. And this is another paper, and this is the recent one by Abbas ETAL, and it's on the evolution of AI in cybersecurity, um, which provides an excellent historical perspective. What it does, it highlights how these early systems relied on predefined algorithms and human generated rules. Again, a firewall is a perfect example which is used in this paper. It uses an intelligent agent that decides whether to allow or block traffic. But its decision is based on a static rule set, like if the source IP address in the blacklist, then block. These systems, if it is not on the IP, then allow the uh, security to run through. And these systems are effective for known threats, but again, this paper notes that they lack adaptability against novel attack scenarios. So, this way, I'm trying to set the background that even our research, our history, our literature says about that the static rule-based system or the expert systems are performing 100% fine on whatever they have been taught, but they are lagging in learning new things. So this is where the learning in machine learning truly changes the game. So what happens? While traditional AI fights the battle of the past, machine learning gives us the tools to fight the battles of the future. I hope you all will agree with me. Uh, I'm sorry. So first, let's talk about anomaly detection. What it does. This is a powerful counter to zero-day attacks. Instead of looking for a known bad guy, the machine learning model will adaptively learns what a good guy looks like, what is the normal network traffic, typical user behavior, or standard file operations. What it does, then it acts like a detective and flagging anything that deviates from his normal behavior and no matter how difficult or subtle it is. So this is how we can identify a brand new threat the moment it appears on the network. And the answer is the anomaly detection. Next, what way we can use machine learning is for the malware classification. What has been done in the past that antivirus softwares relied on the signatures. What it is, a unique digital footprint of a virus, but attackers change their malware to evade this. Now, the machine learning models, however, can be trained on massive libraries of both malicious and the benign code. And they learn the underlying characteristics and behavior patterns of malware, which allows them to instantly classify a new virus they have never seen before, even if it has no non signature. And this is really the power of machine learning. Finally, machine learning gives us predictive threat intelligence, which we really want our systems to do. So now think of the sheer volume of data being generated across the internet, from hacker forums, dark web markets to the social media. Now these AI and ML algorithms have the power to process all of this data to find chatter about new exploits, stolen credentials, or any upcoming attacks. I would say it's like having a crystal ball that gives us a glimpse into the future of cyber threats, allowing us to prepare our defenses in advance. So, this way, we can utilize the power of machine learning models to design more robust and secure systems to fight against the digital arrest and the cybersecurity. And this is an important paper by Gilbert et al. In Computers and Security Journal. And this paper presents a fascinating example of what we are talking about right now. Their work introduces a Hydra, and this is a multi-model deep learning framework. They introduce this framework for malware classification. And the traditional methods often analyze only one type of data, the author says, such as the file's code. However, their proposed model takes a multimodal approach by simultaneously analyzing multiple features. So it could be behavioral API calls, its structural characteristics, and even converting the binary to an image for visual analysis. So by fusing these different types of data streams, the authors have designed a model that can learn a more comprehensive representation of the malware sample. And this makes it far more robust and accurate at identifying new, never seen before malware variants that might evade detection from a single modality model. And this is, I would say, a prime example of how academic research is leading the change in developing cutting edge proactive security defenses. Um, all right, so we have talked about how machine learning helps us catch threats as they happen and identify new ones. But believe me, the true power of AI lies in the ability to predict the future, which we are talking about the crystal ball sitting in the center and we want to predict the future. This is where we move from a reactive security posture to a truly proactive one. That we know that something is going to happen, but what we are going to proactively do against it. So, predictive threat intelligence is about going beyond simply analyzing what's happening on our network. It involves using AI to process an immense amount of data from outside our organization. Uh, think about all that chatter that's happening on the hacker forums, the new exploits being sold on the dark webs, or discussions on the social media. This is a volume of data we as a human will not be able to manage. Even the static AI will not be able to manage. So, what the machine learning algorithms, these are trained to analyze this data, find patterns that signal an upcoming threat. They can connect the dots between discussions about a new vulnerability and the development of specific exploits. So, it's like having a digital detective, detective that's always on the case, looking for clues to prevent a crime before it actually committed. And if you will say the scenario, you will believe that the results will be invaluable. What happens over here that your security teams gets an early warning instead of being surprised by a new strain of ransomware or major phishing campaign, you will have a heads up already. And this gives you and your team to patch systems, update defenses, educate employees before an attack even begins. And this is the ultimate goal of evolving cybersecurity landscape. Now I want to divert slightly and bring in a topic from my own area of expertise to show how these concepts come together in a very practical way. Many of you are probably familiar with digital watermarking in the context of copyright protection, like the subtle logos you see on the stock photos, but it's also powerful cybersecurity tool. At its core, what is a digital watermark? It's a hidden piece of information which is embedded into the digital file. Now, you can think of it like a watermark you see on a physical banknote, the rupees, the notes. We know it's hard to see, but it's always there and it proves authenticity. So, if we talk about a digital watermark, it can be embedded in an image, or it can be embedded in an audio or a video, and accordingly it will be called as the image watermarking, audio watermarking, and video watermarking. Now, according to the way of watermark instruction, watermarking is called as blind, non-blind, semi-blind. And out of these three techniques, blind watermarking techniques are the most difficult to implement. While this digital watermarking, I would say, is great for the copyright protection, its real power lies in the cybersecurity, and that's called as the data integrity. This digital watermarking has two key security application. The first one is the tamper detection. That means if I embed a watermark in a sensitive document and a hacker alters even a single pixel, the watermark can be instantly destroyed. That gives me a clear signal that the file has been tampered with. Now, what it acts? It acts like a digital seal. The second application is the source tracing. Now, let us consider if a confidential document is leaked, a watermark can be embedded with a unique ID for each recipient. Now, if the document shows up on the internet, you can always analyze the watermark to pinpoint exactly who leaked it. And this is the most crucial part of the digital forensics and the incident response. So, how do we bring these concepts together? And my own research in digital watermarking provides a perfect example of how AI and ML can enhance traditional security tool to be more effective against modern threats. The biggest challenge I would say for digital watermarks is robustness. That is, attackers try to remove the watermark without damaging the file. And the traditional methods struggle with this. Even we had a hard time designing more robust, secure digital watermarking techniques. But nowadays, machine learning has completely changed the game. What we can do, we can now train a neural network to detect a watermark even after a file has been heavily compressed or undergone seemingly destructive changes, or it has been altered completely. So I would like to say that the artificial intelligence learns what the watermark looks like in various degraded states, making it incredibly difficult to remove. So no one can remove the watermark completely nowadays if we are using a competitive, effective neural network in the system. In the second point, in a large scale data breach, we can use machine learning for security and forensics. Now, you just imagine thousands of leaked files. A security team can use a machine learning model to quickly scan these files to find a watermark that can identify the source of the link. But do you think that this task would be possible for a human to do manually? Nearly impossible, or it will take a years, thousands of years to do so. So finally, artificial intelligence can assist in the creation of the watermark itself, first of all. What type of watermark we should embed in the image or audio or video. And algorithms can also analyze the host file and embed the watermark in the most resilient way possible. This will make it even harder for the attackers to remove it without even destroying the integrity of the original data. So this is the power of again machine learning or AI in the area of cybersecurity, wherein we are using the digital watermark or digital watermark technology, putting in all together. Let us have a look at a research paper. Now, as we discussed on the last slide, that a key challenge for any watermarking system is its robustness, which means that the ability to survive various attacks, ability for a watermark to survive against various attacks. Now, this is precisely where AI, machine learning, and deep learning provide a powerful solution. And this paper is a fantastic and cutting edge example of it. What this paper do, this presents a blind watermarking system which is built on a deep learning model. If you look at the title, the blind term is very important here. What does it mean? It means that a system can successfully extract the hidden watermark without needing the original unwatermarked image. And this is the significant advancement for real world application which we actually need. Now, how does it work basically? The system uses a deep learning model with two main components. It has an encoder that embeds the watermark and a decoder that extracts it. Now, the real innovation lies in how the authors make the system robust against attacks. So, what they have done, they strategically added noise layers to the models to train it to withstand various common image manipulations and the compression techniques. And most importantly, the paper uses the adversarial training to further enhance the robustness. And this directly connects to our next discussion on the next slide on the dark side of AI. And in this context, the model is trained against a virtual adversary whose only goal is to remove the watermark. So, by learning to defeat this adversary, the watermarking system becomes, I would say, incredibly resilient. And this is a very compelling example of how AI is used to proactively defend against future attacks. And finally, the author also uses a two-step training technology to optimize the model's accuracy and performance. Now, the key takeaway over here is that artificial intelligence is not just a simple add on. What it does, it is a fundamental part of the design that makes the watermarking system effective and then secure against modern cyber threats. Uh, okay, so the dark side of AI. Up to this point, what we have discussed so far, we have seen the immense power of AI in cybersecurity. But it is also crucial to have a balanced perspective. And artificial intelligence is not always a silver bullet because it introduces new and significant challenges. Every, gain comes with the pain, we all know. And one of the most significant threats in the rise of is the rise of adversarial attacks. Now, this is where an attacker intentionally designs data to fool an AI system. For example, let us consider a cyber criminal that might add a few small, unnoticeable changes to the code of a malicious file. Now, to a human, the file looks the same, but the changes are specifically designed to trick an AI malware detector into thinking the file is harmless. And this is a new type of attack that we have to defend against. The other major challenge is related to data. We know AI models need massive amounts of data to learn. And in cybersecurity, this often means sensitive data from network traffic, user behavior, and the system logs. So, what it does, this brings up the serious concern about, first of all, the data privacy and security. Furthermore, if our training data is biased or incomplete, the resulting AI model could have blind spots or it is biased. So, what it will do, it will make our defense weaker in unexpected ways, which we cannot even think. So, where we do go from here? The future is not just about using more artificial intelligence, it's about using it smarter and a more collaborative way. We people should start thinking about it. The first part to discuss over here is the explainable AI. Now, today, many powerful AI models are like black box. They gives us an answer, but we don't know why. In cybersecurity, that's a big problem. So what we need to do, we need to know why an AI flagged a critical security alert. So a human analyst can verify it. Let's say if I know that there is a critical security alert, I as a human analyst should be able to verify it. But machine learning models, deep learning models doesn't give answer to this. This is where the explainable AI plays the role. So now the goal of the explainable AI is to build more transparent models that can explain their reasoning, which in turn builds the trust and allows our human experts to learn from the artificial intelligence. And the most important takeaway over here is that the future of cybersecurity is not about replacing people, which we as a human beings have a tendency to think about it. It's basically about human in the loop collaboration. So AI will handle the routine, high volume tasks like shifting from thousands and millions of logos to find an anomaly. This frees up our talented security professionals to focus on the strategy building only, rather than working on a single file to looking for the malicious attacks. And finally, we may eventually see a future where the battle is between two intelligent systems and attacking AI designed to find vulnerabilities and a defending AI designed to patch them in the real time. So I would say it's a fascinating and rapidly evolving field. This paper will give you a complete overview of the similar thing what we have discussed. And the biggest hurdle for our most powerful AI model is the black box problem. And they make a decision, but they can't explain how they reached it. And this is critical issue in high stakes fields like cybersecurity. And this survey paper is by Zhang et al. And it is a piece of literature that directly addresses this issue. Now, in this paper, the authors note a surprising fact that despite the extensive use of AI in cybersecurity, there was a significant research gap in understanding how to make these models more explainable. And their paper aims to be the first comprehensive survey on the topic. These authors have perfectly articulated the core issue of the deficiencies of the transparencies in the current AI models, which decrease human users' confidence. And what they do, they point out that security experts who are dealing with increasingly diverse and complicated attacks need to comprehend, trust, and manage these next generation defense mechanisms. So, without transparency, it's impossible for them to do so effectively. And what does this paper do? This paper reinforces that the explainable AI is the essential solution. It's not about making AI less accurate, it's basically about maintaining high accuracy while providing the interpretability that allow human operators to understand and act on models' conclusions. I have one more paper, I believe. Yes. So this is a literature survey by Charmet ETL, and they also give a fantastic overview of this exact intersection. Now, in this paper, the authors highlight the core problem with the deep learning in the security, which says that the models are very excellent at the detection and prediction, but they are incapable of justifying their results. And their paper investigates the topic from very interesting perspectives. They have used two perspectives. I believe the first one was to review the existing applications of XAI to cyber security, and then secondly, they discuss the security of XAI itself. And this paper concludes by formulating a set of open questions that are either unanswered or insufficiently addressed in the literature. All right, so key takeaways. We have covered a lot of ground today, and I would like to leave you with four key takeaways to remember. First, the most important thing to understand is that cybersecurity landscape has fundamentally changed. Nowadays, it's no longer static, and because of this, our rule-based defenses and our old defenses are no longer enough. For that, we need a new approach. We discussed it. And secondly, I hope I have clarified the misconception that AI is not only machine learning, it is far beyond that. Remember that AI is a big picture. The goal of creating intelligent machines have been there both, and ML is just one powerful method to achieve this goal. Thirdly, the true power of machine learning lies in its ability to give a proactive defense rather than working reactive only. And by learning from the data, it allows us to predict threats, predict future, and detect new attacks before they cause serious damage to our network. And finally, the future of cybersecurity isn't just about machines replacing us, it's about human AI collaboration, and AI will handle the data and routine tasks, freeing up our human security experts to do what they do best: strategize, innovate, and make the complex decisions that ultimately keep us all safe. And I would like to say thank you very much for your time and for your attention today. I hope this session has provided you clear understanding of how AI, starting from the basic, moving towards the machine learning, is shaping the future of cybersecurity and has inspired you to think about, I would say, these concepts in a new way. I would be happy to answer any questions you might have about the topic we have discussed. So please feel free to ask.
Yeah. Thank you, Dr. Rashdeep. It was very nice session, wonderfully depicted the role of artificial intelligence and machine learning in cybersecurity. I request all the participants, they may raise their hand and ask any question about the session, and they may also drop the question in the Q&A section, so we can ask the question on their behalf. So any question is welcome. Dr. Arun, is there any question?
Mr. Manoj Raman, he have raised the hand.
Hello,
Yes,
ma'am.
please.
Hello, Ashdeep ma'am. Am I audible?
Yes, you are audible, Raman.
Yes.
Okay.
Please
Okay.
go
Madam,
ahead.
my question is that like I have worked for a law enforcement agency and we probably get the kind of videos which are already mocked, like layering has been done, especially in case of the like pornographic videos from a woman victim. So each time we find this difficult to remove this overlapping or layering from that video. So is there any kind of tool or any
Sorry
technique?
to interrupt you. There is a lot of noise from your end, and I'm not able to understand your question. Could you please
Yes.
repeat?
Okay, okay. So my question is simply, we probably get the videos which are layered videos,
Okay,
what we call
Manoj,
sorry.
Let me ask you a question. He has also dropped this question in the Q&A section. Is it possible to remove a watermark using AI? Like
Right, right. This one.
as LEA receives many videos which has been layered intentionally, like mobbed. Please suggest a research paper or any available tool to remove a watermark.
All right. So, this is removing a watermark from, a image or audio or video, any type of media using artificial intelligence nowadays is possible. But again, ensuring that the host or the decoder will not be able to know that the watermark has been removed or it was existing completely. It's a challenge nowadays. If I have a smart way of removing the watermark from the image or video or audio, I have the smarter way of detecting that whether the watermark existed or not. And Dr. Manoj, if you want some research paper wherein you are seeking process to remove watermark using AI from the system, I can share some useful insights from the literature. I hope you can see my email ID on the screen or I here. And please write to me. I will get back to you with the existing literature which I have with me, and you can explore it further. I hope this answer your query.
Mr. Manoj? Okay.
Yes, sir. I have already sent a mail to ma'am, and I hope I will get some resources from there.
Okay.
Thank you. Thank you.
Thank you.
Another question by Dr. Rameshwar.
Dr. Rameshwar.
Yes. How can AI and machine learning be leveraged to enhance cybersecurity threat detection and response, particularly in the context of emerging threats such as adversarial attacks and next-level AI, XAI? And what are the most effective strategies for integrating AI-powered security solutions?
Mm,
Have you got the question?
yeah, it's
Really?
hard to understand
Okay,
the
okay.
voices.
He has also dropped the question in the WhatsApp group, actually. He's
Mhm.
asking how can AI and machine learning be leveraged to enhance cybersecurity threat detection and response, particularly in the context of emerging threats such as adversarial attacks and explainable AI? And what are the most effective strategies for integrating AI-powered security solutions?
All right, so I believe that my whole presentation walked through this question, wherein I have answered that how AI and ML can be used to fight against various attacks, especially the adversarial ones which exist. Uh, AI and ML algorithms can be used in the field of cybersecurity by ranging starting from very basic, I would say, the rule-based system, and then moving on to the more advanced machine learning algorithms. How basically we are using these systems, I can teach my system to see. Let us consider an example of an email. Uh, I hope all of you are aware of the spamming and not spamming concept, wherein I teach my system that I will give some of the information that if you see emails from such sources or with such keywords, consider that email as a spam and that should go into the spam. This is one of the very basic example to be considered over here that we can work with the secure systems. Definitely, there is a lot of work and research going on in this field, and still there is a scope to work more in it.
Dr. Arun, any other question? Okay. Dr. Jayashree Katti has a feedback. It's a really simple yet informative session. And Dr. Vijay has also said it's a wonderful session. Dr. Rupali Jaina, Dr. Saima, all have given a feedback about the session. It was very interesting and interactive. Thank you all the participants for sharing your feedback and your questions. It's all about any other question, Dr. Arun? No. No question. Okay, no more question then. It was really, really wonderful session. Thank you very
All
much.
right.
Dr. Kaur, for such a thought-provoking and insightful session on the evolving landscape of cybersecurity, a look at AI, not just machine learning. Your talk has shed light on how artificial intelligence is transforming the future of cybersecurity, going far beyond the conventional machine learning approaches. The clarity with which you explained the concepts, the real world applications you highlighted, and the futuristic perspective you brought into the discussion have been truly enriching for all of us. On behalf of the Satya College of Engineering and the participants of this FDP, I sincerely express our gratitude for your valuable time, expertise, and inspiring contribution. Thank you so much. We hope to have more opportunities to learn from your knowledge and experience in the future. It was really a wonderful session to have you with us. Thank you so much, ma'am. Thank you. Thanks a lot.
Right. Thank you. And I want to sincerely thank all of you, the organizing team, especially Dr. Gagan, for
Thank you.
having me on board, and all the active participants over here. And thank you again, and have a great rest of your day. I would like to add one more thing. Nowadays, I'm working on a project, and we are seeking funding from the US government.
Yeah.
So if anyone, so basically we are looking for the students and the faculties who are very good in programming. So we may have one or two students from India on board, and those will be virtual right now. If anyone want to collaborate, please drop me an email. But we need good programmers in Python. Those who
Python.
have
Yeah.
good, yeah, Python.
Yeah. Dr. Paritosh, sir, are you there? Yeah, we have a good faculty member among us. So,
Yeah, so yeah, we
some
will
good students
definitely
are
look to
also there.
collaborate. A
Yes, please.
faculty who can collaborate from India, and we can.
Definitely, ma'am. Definitely, definitely.
So
Thank you.
opportunity.
Thank you.
All
Thank you.
right, thank you. Thank you so much. Thank you all.
Thank you, ma'am. Thank you. Good day. Thank you all the participants. So this marks the end of the second day of this FDP. And I wish everybody a good night and happy Ganesh Puja. And then we have Ganesh Puja, Ganesh Chaturthi tomorrow.
Tomorrow,
So
yeah.
10 days festival in most part of the country.
Nice.
So
Yeah.
happy Ganesh Puja to all of you. Good night. Feedback form will be shared to the WhatsApp group. So all are expected to share feedback about this session and the previous session on that feedback link. Thank you so much. Good night.